So my project is called a Reader Control Mower Bot. So a machine is any device that makes you get work done more quickly or more easily. So in order to make a machine, you need to understand the parts involved to make it and how each part interacts with each other. So currently many devices are made programmable, so that way they can do tasks with no human intervention, and this also helps disable people because their life is much more harder than ours. So having a robot do the task for them makes their life so much more easier. So I wanted to make an automatic lawn mowing machine, or at least a concept of this machine, that can mow the lawn by itself without too much human intervention. So my goals for doing this project were to first make the robot and make it programmable, and then I wanted to make a code so that way it can mow the lawn without too much human intervention. I wanted to test this robot on different shapes and different slopes, and I wanted to add a 3D printed design on the top so that we can protect our motherboard, our most important part and fragile part of the robot. So here are my materials. So how we made the robot is that we first bought a kit, but we made a few modifications to it. We drilled a hole on the bottom, and then we attached the motor on the bottom. We attached a propeller to this motor, and it made the motor functional by attaching the wires to the blade, to the motherboard, I mean. And then, so this will illustrate the propeller cutting the grass, the blade cutting the grass. So next we worked on the code. So here's our flowchart, here's a visual diagram, and here's our actual code. So how the code works is that first, the robot goes forward. Then the IR sensor will sense the black line and make it go a little bit to the right and head back. Then the robot will correct itself and go forward. So keep on doing this all the way to the end. At the end, if only one sensor sees, at the end, we have 3 sensors on the bottom, but if only one sensor sees the black line, and then the robot will stop. So some of the challenges that we had to deal with was coded. Is that the robot was sometimes not traveling straight, so we had to make one set of wheels go a bit faster, one set of wheels go a bit slower in the code in order to make it go perfectly straight. Sometimes the robot was too fast to see the line sensor, so we had to make the robot slow enough to always see it. I could not make the robot turn at an exact angle, so we had to do a lot of trial and error to find that. And the IR sensor is only the back, so the robot would always have to cross the boundaries in order to follow the program. So next I tested it on different shapes. I tested it on a rectangular shape, a simple yard shape or the shape of our backyard, and a circular shape. So the rectangular shape, so sometimes, like we said earlier in the code, sometimes the robot, when it ever sees the black line, the robot will stop. So sometimes in a regular shape, the robot will just stop completely without ever completing its course. So we needed to restart the robot in order to let it finish. The rectangular shape, we just started it and was able to do the entire thing. The simple yard shape, however, it stopped twice, so we had to turn it. And the circular shape, since we noticed that curves were a lot more harder for the robot, so if the robot wasn't able to, it had a lot of restarts, so we had an average about 4, but we couldn't, So next we tested it on different slopes and different slopes. So we tested it on a 1.3 centimeter slope, a 2.8 centimeter slope, and a 4.0 centimeter slope. So we then tested, so the robot was able to do the 1.3, 2.8, and 4.0 centimeter slope, do all of them with no problem. So after that, we created a 3D printed design. So what I did was that I downloaded a software called Autodesk Moto 3D Design, and CADed an image, which then, once I CADed it, I 3D printed it out at my mentor's 3D printer, so that way we could have a cover for our motherboard that can protect our motherboard from things like dust and branches, so that way the most fragile and important part of the robot won't be harmed when it's outside. So by doing this project, I was able to learn the different parts of the motherboard, the Arduino programming language, and the Autodesk 123D design. So the future ideas of this project may include adding a blade strong enough to cut grass, making the robot larger with stronger motors to run on glass, and adding a compass module which will make the coding much more easier, adding an ultrasonic sensor which can detect 3D objects and obstacles like trees, and try other ideas like making the robot shovel snow off the driveway. So by doing this project, I learned the importance of robotics like military usage, medical procedures, household